All right, for helping out in the homework for section 2.6, we did this section in 2 days, so I'll do one problem from day 1 today, and then I'll show another video for day 2. Day 1 deals with graphing with vertical asymptotes and horizontal asymptotes. And so I know, because this is in section 2.6 day 1, I know it's going to be dealing with a horizontal asymptote, but I need to be able to figure that out on my own when I'm taking the test. So when I look at that, how do I determine it has a horizontal asymptote? Remember, look at the degree of the numerator and the degree of the denominator. It's going to have a horizontal asymptote if the degree of the numerator is smaller or the same as the denominator's degree. If the numerator's degree is bigger than the denominator, then it's a slant asymptote, and that's when I'll end up dealing with tomorrow. So make sure that you can identify whether it's a slant or a horizontal. So I know this is going to be horizontal. Now, because it's a horizontal, my first step should be to try to factor the numerator and denominator as far as I can. So the numerator is simple enough. It factors into x minus 2 and x plus 1. The denominator I'm going to have to do synthetic division on. And so if I make my little plus or minus list, I've got plus or minus, it's factors of 6 divided by factors of 1. That's nice. So it's really just the factors of 6. And yeah, it's going to take me a little time to guess and check to figure out what this is. If you remember what we did for the homework when we were doing synthetic division before, we said if you want to use your calculator to maybe get you through the guessing and checking a little quicker, you could do that. I happen to know that one is going to work, so I'm going to run through and show that it does. Even if you use your calculator to help you figure out what the numbers are, I still want you to show what you're doing algebraically so that I can see that you actually know what it is that you're supposed to be doing. And so I run through, and sure enough, I get 1 to work. So it's not that I want the x-intercept of x equals 1. That means it's a factor of x minus 1. Remember, this represents x squared minus x minus 6, and that factors into x minus 3 and x plus 2. All right, so our first step that we had said was to try to factor our function as far as you possibly can. And then you're going to start to list out kind of the important information that you need. So there's a few things that we find, and usually the first thing we find is, what are the vertical asymptotes? All right, go back to your function, see if anything will cancel or simplify, and nothing does. The x minus 1, x plus 1, they don't cancel. X plus 2, x minus 2, they're close but don't cancel. The x minus 3, they don't cancel. If anything cancels or simplifies, you want to do that first because that represents a whole. We don't have any, so all of these things in the denominator are vertical asymptotes. So I've got one at x equals 1, I've got one at x equals 3, and I've got one at x equals negative 2. Can only have one horizontal asymptote, and it goes back to the rules here. Since the degree of the numerator is smaller than the degree of the denominator, it's automatically at y equals 0. If they were the same, then you would divide the leading coefficients. All right, we said because nothing canceled, we don't have a whole. I'm just going to say that there's none. And then the other thing I have to do is, does it cross the horizontal asymptote? Because it's possible that that happens. And so what you have to do is you have to take the simplified version of the function, which it didn't really simplify, set it equal to whatever the horizontal asymptote number is, and that from problem to problem that can be different, and then solve. So I'm going to set this function equal to 0 and solve. And of course, if I do that, when I cross multiply, that is just going to disappear because it's getting multiplied by 0. And so it looks like 2 and negative 1 are the two places that it crosses. And now I've got all of my important information. I can go ahead and I can set up my graph using that information. So I am going to do that right below it here. And it's not overly important that I have tick marks that are evenly spaced, but you want to try to keep it as uniform as you can. Once you get all of your tick marks in, you can go ahead and start graphing your asymptotes. We said we had one vertical asymptote at x equals 1, dashed line there. And I like it if you can put x equals 1 above it, just so I can, when I'm looking at it, I can quickly identify what asymptote that is. X equals 3 is a vertical line right here. And x equals negative 2 is over here. Now, because the horizontal asymptote is right on the x-axis, if you want, you can kind of make it bold like this, or you can move it up or down just above or below the axis so that you can actually see it. A lot of times when you're looking in the book, they won't have anything there. You just have to assume or know that it's there. So that takes care of the vertical asymptotes. Horizontal asymptotes, I didn't have any holes to worry about. Okay, it crosses. It crosses at x equals 2. So right on the horizontal asymptote, I'm going to put a little x with a circle. You can do whatever you want. This just reminds me that I need to go through that point. At -1, that is right here. Right on the asymptote, you want to put that x. And now I'm ready to start doing test points and drawing my graph. I have 4 regions that I have to pick test points for. I've got this region here from -2 on to -infinity. I've got that region from -2 to 1. I've got the region from 1 to 3, and then I've got the region from 3 off to positive infinity. And when you look at the region from 3 to positive infinity, it doesn't cross here, so my graph is either completely above it or completely below it with a curve that looks something like that. On the far left here, it doesn't cross out here, so it's either completely above or completely below. If it didn't cross, it obviously does here, but if it didn't cross in between asymptotes, that's where you end up with the little parabola shape. Because it does cross, that means I'm going to end up with that little S shape that looks like either this or this, and test points are going to help me figure that out. Same here. It would be a parabola if it didn't cross, but because it does, I am either looking at that little S shape or that little S shape. And so now I'm going to go to my test points. I'm going to rewrite the function, the factored version of it right here, just because you can't see it on this video right now. So here is the simplified version. Now it didn't simplify, but if it did simplify, you'd want to use the simplified version. You don't have to, but it just makes it a little quicker. And I'm going to pick test points in each one of these regions. So I always do the far right and far left first. It doesn't really matter. So I'm going to pick this region here. I need to pick something to the left of -2, so I'm going to pick -3. And please show your work for this. This is the way I kind of like doing it, putting the number in with a box around it and then drawing an arrow to the side and then doing my work. So let's say I plug in -3. That is going to give me -5 times -2 divided by -4 times -7 times -1, which is going to give me +10 over -28. Now realistically, all I need to know about this number is it above or below the horizontal asymptote number, which we said was 0. It's negative, so it's definitely below. So I picked a number that was to the left of this asymptote. I got a number that was below this asymptote, so I am looking at this region in here. So my curve is going to look something like this. And of course, as it approaches those asymptotes, it starts to bend. Alright, so let's try a number on the far right. Here's 3. I need something to the right of that. I'm going to pick 4. Now, the good news is I don't have to actually plug the number 4 in here and calculate what that number is. This is 0. So, and this is the only time you can do this, but when this is 0, all I can do is pay attention. Is it a positive or a negative number? So for example, if I plug 4 into that first parenthesis, it's a positive number. Plug it into the second parenthesis, it's a positive number. Jump to the denominator, plug 4 in here, it's a positive number. The second one would be a positive number. The third one would be a positive number. I have all positive numbers, so if I multiply and divide positive numbers together, it's going to be a positive number, which means it's bigger than 0. Again, I can only do this little plus or minus trick if this is 0. If it's any other number, then I have to figure out what the number is and ask myself if it's above or below. If you're not sure when to use it, then always figure out the number. Alright, so I picked 4, which is out in this region here. I got a number that was above 0, so it's this region here, and my curve should be kind of close to the asymptotes as you go up and to the right. Now jumping into the middle. So I'm going to try this region here first, the one between -2 and 1. I know it's not a parabola because it actually crosses. I'm going to pick a number that looks easy. 0 looks like an easy one to pick. I cannot pick the crossing point, so I'm going to put 0 in here. And I'm going to do my little plus or minus trick, and it's going to give me -2 if you actually want to calculate it, +1 if you actually want to calculate it. Gives me in the denominator a negative number, a positive number. When I look at the number of negatives I have an odd number of them, so I know that this is actually going to be negative. And now I need to pay attention to where 0 was. 0 is in between this crossing point and this asymptote. and it's below the horizontal asymptote. So it's down here somewhere. Now as this graph goes to the right, it has to bend because of the asymptote, but it has to go through here, so it's going to look something like this. Where as I go to the right, this thing is eventually going to bend because of the asymptote. Crosses, which means it's now up here, and because of this asymptote, you think it'd just go to the left forever, but as it goes to the left, it's got to bend because that asymptote won't allow it to touch it. And so your curve looks something like that. If this had been a positive number, then I would have been up here, and it would have curved and looked like that. All right, we're going to do the same thing here for this region. Picking a number between 1 and 3. 2 sounds like a good number, but that's actually the crossing point, so I can't pick that. I'm going to pick 1.5. I have to pick something that is not the asymptote or the actual crossing place. And yeah, it's not the greatest number to have to pick, but because I can do my little plus or minus trick, it actually is not so bad. Plugging 1.5 into that first parenthesis is going to end up making it negative. Second parenthesis would be positive. In the denominator of the first parenthesis is positive. Second one's negative. Third one would be positive. And if I look at 1.5, because I have an even number of negatives, that number is positive. So 1.5 is right in here, and it's positive, so that means it's up here. It's got to curve down to that crossing point. As I go to the right, it's going to get next to that asymptote and curve again. And so my graph ends up looking just like that. Alright, that is the homework help for 2.6. Just a kind of a reminder, if you do have a hole, you want to double check that at the very end. We obviously don't have one, but say I had one at x is equal to, say, 4 or 5, I would want to come over here. Here's where the x value of 4 is, and I would want to physically put a hole in there. So just be careful with that, since we didn't actually have that. Alright, let me know if you have any questions or need any help.